right, so today we are starting a new section. We're in section 2.2, and we're talking about polynomial functions. We're going to look at some different kinds of polynomial functions here and some different key features about these polynomial functions. So first of all, what is a polynomial function? Well, a polynomial function has a graph that has no breaks, holes, or gaps. So it's just one continuous movement there. And it only has smooth, rounded turns. So these first two graphs here, these would be polynomials because they're nice and smooth, continuous movements here. These are examples of not being polynomial functions. For this one, you see that there's a break right here, so it's not continuous. And then on this one, you see it has a sharp turn instead of being nice and smooth. So those would not be polynomial graphs. All right, let's go on to the next page. Oops. All right, so this is talking about the end behavior of polynomial functions. So end behavior means what are the ends of the graphs doing? So let's look at this example, this x to the fourth minus 4x squared. So the end behaviors would be here and here. So for this example here, as we approach x equals negative infinity, so the more we go to the left here for the x values, the function is going up. So this is approaching, f of x is approaching positive infinity. So we could say, as x approaches negative infinity, f of x approaches positive infinity. And if we look over here at the right side, the right-hand behavior, x is approaching positive infinity here, and so is f of x. F of x is also approaching positive infinity. So we could say, as x approaches positive infinity, f of x also approaches positive infinity. All right, you try this next one. Pause the video. All right, let's see how you did. So we're looking at the end behaviors. So here are my ends. Here's my left end and my right end. And I could say over here, as x is approaching negative infinity, f of x is going down. So it's also approaching negative infinity. And you would say that like this: as x approaches negative infinity, f of x also approaches negative infinity. And over here, x is approaching positive infinity, and so is f of x. F of x is going up, so it's approaching positive infinity as well. So that's left and right hand end behavior of the graph. And there's some rules for this. So what determines how the ends of the graph rise and fall? So, and this is called the leading coefficient test. So we're looking at a couple things. We're looking at that first term here, okay? So the A sub n here stands for that leading coefficient, the first number you see there. So when, what we're doing is we're looking at that leading coefficient, and we need to determine if it's positive or negative. And then we're also looking at the exponent, or the degree here, the n, and then we need to determine if that's even or odd. So when n is odd, or the degree is odd, there's two cases. When you have an odd exponent, you could either have a positive leading coefficient, so that number out in front is either positive or negative. And then the second case is when that degree is even. So the exponent, that first highest exponent is even, and then you would look at, is the leading term, is the leading coefficient positive or negative? And then you would use this chart to figure out what the end behaviors are doing. So let's look here at number 3. And we're getting into our first learning target. I can describe left hand and right hand behavior of the graph of the polynomial. So what are the left and right side? If we were to graph this equation, what are the left and right sides of the graph doing? Well, first you need to make sure the equation is in standard form. So step 1, make sure equation is in standard form. So let's look at this. We want to make sure we have the highest exponent down to the lowest. So x squared, x constant. So it's good, it's in order. So step 1 is good. All right, step 2, we want to determine if our leading coefficient, I'm going to just call it the LC, determine if the leading coefficient is positive or negative. All right, so my leading coefficient here is -2. So my leading coefficient is negative. Now I'm going to look at the degree. So the highest degree would be x squared, so 2 is my degree. And I'm going to determine if the degree is even or odd. So I said my leading coefficient is negative, and my degree is 2, so that is an even number. Degree is even. So I have a negative even situation here. So I'm going to use my chart. So step 4, refer to chart. Refer to chart. All right, there's my steps. Put it in standard form. To figure out if leading coefficient is negative or positive, degree is odd or even. Now I'm looking at my chart. So I'm looking for a negative even here. So right here, negative, even. So it's going to look like this. My graph will fall to the left and the right. So both ends are going to go down. So there's my answer. Graph falls left and right. So what does that mean in terms of x and f of x? Well, over here, as I approach negative infinity for x, I'm also approaching negative infinity for f of x. So I would say, as x approaches negative infinity, f of x approaches negative infinity. And then over to the right, as I'm going towards positive infinity in the x direction, the function is also going down. F of x is also approaching negative infinity. So as x approaches positive infinity, f of x approaches negative infinity. Direction going down, falling left and right there. All right, you try number 4 on your own. All right, let's see how you did. So you have to make sure it's in standard form. 3, 2, 1, we're good. And then I'm going to find my leading coefficient. It's -1, so my leading coefficient is negative. And then my degree is 3, which is odd. So I'm looking for a negative odd, so it's this one right here. So the graph rises to the left and falls to the right. Graph rises left and falls right. All right, and then we will describe it. So as x is approaching negative infinity here, f of x is going up, so it's approaching positive infinity. And then over to the right side here, x is approaching positive infinity. And f of x is going down, so it's approaching negative infinity. Okay, go ahead and turn the page. Nope, wrong one. And try 5, 6, and 7 on your own. So go ahead and pause the video. Try those on your own. All right, I'm not gonna go through these all, but I'm gonna show you the answers and we'll talk about it here. So number 5 is a positive odd, so it's gonna fall left, rise right. X approaches negative infinity, f of x approaches negative infinity. X approaches positive infinity, f of x approaches positive infinity. Number 6, leading coefficient is positive, degree even, so it's going to rise right and left. And there's your description there. And then number 7, so number 7, you have to kind of expand it to see that your leading coefficient term is x to the third. So my leading coefficient, 1x to the third, that would be a positive odd there. So that's going to fall left and rise right. And there's your description there. Okay, so that is called the leading coefficient test to determine your end behavior. So let's move on to our next learning target. So now we're talking about zeros of the polynomial. And we've talked about zeros before when we were looking at quadratics. Okay, so some key points to know. The max number of zeros of a polynomial is the degree of the polynomial. So like, for example, this one has a degree of 5, so the most zeros this polynomial could have would be 5. So that's what that means there. All right, and then these zeros are also the x-intercepts, and they're also called zeros, roots, x-intercepts, zeros, roots, all interchangeable there. And this is where the graph crosses or touches the x-axis. Something new we're going to talk about is multiplicity. So multiplicity is a number of times the factor occurs. And we'll look at what that means. And that's multiplicity. And this determines if the graph touches the x-axis or crosses it. So crosses or touches. So if it crosses, this is going to be an odd multiplicity. And when it touches, this is going to be an even multiplicity. And again, we'll talk about this more as we go through these examples. So odd crosses and even touches. One more new thing we're going to talk about is the number of turning points. So these are the max and mins, all right? So how many max and mins? So where does the graph change from increasing to decreasing or vice versa there? And that is figured out by n minus 1. So again, let's look back at 5. We'll use this as an example again. N is 5 here. The degree is 5. So I would do 5 minus 1 is 4. So this polynomial would have at most 4 turning points there. Okay, so let's get into this. So here's our first example. It says the graph of f of x, and then there it's given to you, is a 7th degree polynomial. So if you were to expand all this, you would end up with x to the 7th of some form as a leading coefficient, because it tells us it's 7th degree there. So a 7th degree polynomial can have at most 7 real zeros. That's the max number of zeros. And at most 6 turning points. So remember, turning points, you do n minus 1. So since we know it's 7th degree, you would do 7 minus 1 is 6. So that's where that came from. And then the zeros are given here. So this would be x equals 2 and x equals negative 3. So at x equals 2, that means there's 4 of those. So x equals 2 has a multiplicity of 4. And then x equals negative 3, there's 3 of those, so it has a multiplicity of 3. So what does this mean? So since there's a multiplicity of 3, that's odd. So that means that this graph is going to actually cross over the x-axis at negative 3. So look at your graph. Here's negative 3 and see how it's crossing or passing through there. So because it's odd, it's going to cross the x-axis. And then this one's 4 is even. So at 2, it should only touch. See how it only touches? It doesn't go past 2, doesn't go through it, it just touches it. So since it's a multiplicity of even terms, then it's only going to touch the x-axis. All right, so that's just a little intro. So let's get into doing these ourselves. So we're gonna hit 3 learning targets with this. So the first learning target is I can find the zeros. And then once you have those zeros, I can determine the multiplicity of each zero. And then finally, I can identify the max number of turning points. All right. So 3 learning targets there. Let's get into it. All right, number 7. F of x equals 25 minus x squared. So first we need to find the zeros. All right, I'm gonna try to write small here. Step 1, we're going to set our equation equal to 0. Set equation equal to 0. So 0 equals 25 minus x squared. Now we need to factor. So we want to break down this 25 minus x squared into factors. So this is a binomial, it's a difference of squares. So I'm going to take the square root of 25, so 5. Signs are always plus and minus. Square root of x squared is x. All right, it's factored. Now we can set each factor equal to 0. Set each factor equal to 0. So 5 plus x equals 0, and 5 minus x equals 0. And then solve for x. So x equals negative 5. And that would be negative 5, carry it over, so positive 5. All right, so there are my zeros. X equals negative 5, x equals 5. So we found the zeros. Now we're going to use these zeros and determine the multiplicity. So the multiplicity is the number of times each factor occurs. Okay, so my first factor is -5. How many -5s do you see? Well, just one. So x equals -5 has a multiplicity of 1. Same thing here, x equals 5. There's only one 0 that's x equals 5, so that's a multiplicity of 1. So the multiplicity of both factors is 1. And what does that mean? What does that tell us? Well, 1 is an odd number. So an odd multiplicity tells us that at these x's here, at these zeros, it's going to cross over the x-axis. All right, so this is odd, which means it's going to cross the x-axis at -5 and 5. All right, so that's multiplicity. Last thing we need to do is determine the max number of turning points. All right, so max number of turning points is degree minus 1. Degree minus 1. So my degree of the polynomial is 2. So my max number of turning points is 2 minus 1. 2 minus 1 is 1. So I have one turning point here. Okay, you give number 8 a shot. Try that one. All right, let's see how you did. So step 1, set it equal to 0. And then factor it. So I'm going to bring down the 4x, and I'm going to see if I can factor this trinomial further. That would be x and x. Then I'm looking for the factors of 9 that add to -6. That would be -3 times -3. -3 times -3 is +9. But -3 plus -3 is -6. Now I'm going to set each factor equal to 0. And solve for x. Now I'm ready to determine multiplicity. So the multiplicity of x equals 0 is 1. Which is odd, so that's going to cross the x-axis. All right. And then the multiplicity of x equals 3 is 2 because it occurs twice. 1, 2. And that's even. So what does that mean? That means it's only going to touch at 3. It's not going to pass through. So it's going to touch x-axis at 3. And then finally, my max number of turning points. Well, for this one, you need to figure out the degree of the polynomial. So originally, you would have to distribute this through. So 4x times x squared is 4x to the third. So that's my leading coefficient there, 4x to the third. So my degree is 3. So for my max number of turning points, I would do 3 minus 1. So there's 2 possible max turning points there. All right, go ahead, turn the page, try number 9 on your own. So this is the last one we're going to do today. We're going to go ahead and skip 10, and then we're going to save 11 for tomorrow to do a quick review. But number 9, let's check to see how you did. Well, first you have to set it equal to 0. And then you can recognize that your GCF is x squared. So you take out an x squared for your GCF. And then you would have x squared plus 8x minus 20 left over there. And then you would continue to factor, looking for the factors of negative 20 that add to positive 8. That would be negative 2 and 10. Set each equal to 0 to find your zeros. So x is 0, x is 2, and x is negative 10. Each one of these zeros only occurs once, so the multiplicity of all the zeros is 1, which is an odd number. So since it's odd, that means it's going to cross the graph at these points. It's going to pass through the graph, or the x-axis at those points. And then your max turning point, you would find the degree, so that would be 4 minus 1 equals 3. So the max number of turning points is 3. All right, that's it for today for notes. So make sure you get your homework done. I did post the key to check your answers there to help you out.